This session we discuss about the last logical connective, the so-called the biconditional. Now, biconditional, let P and Q be two propositions. Then the biconditional denoted by is a statement P if and only if Q, or you can say is a statement P is necessary and sufficient of Q, or you can say P is necessary and sufficient for Q, or you can say P is implies and implied by Q. So those are different meanings of the connective biconditional. So let's do some examples. So if we say P is the sugar process to the decay, and then the other proposition Q, we say 3 plus 2 is less than 10. Then the biconditional of P and Q will be sugar process tooth decay if and only if three plus 2 is less than 10. Or we can say sugar process tooth decay is necessary and sufficient of 3 plus 2 is less than 10. Or if that's not the language you want to use, you can say sugar process tooth decay is necessary and sufficient condition for 3 plus 2 to be less than 10. Now, the biconditional what we call double implication is defined as, so the biconditional of P and Q is taking the implication P implies Q, and then and Q implies P. I hope you can clearly see that if this is the way we are drawing these arrows, one to the right, one to the left, so it's like we are taking an arrow to the right and then another arrow to the left. So that's why we are saying that this is the way we define it. Taking arrow to the right and arrow to the right from P to Q and then Q to P. So this now can help us to draw the truth table. With this, because we have already understood how to write the truth table for the implication. So let this be P, let's have Q, let's have P implies Q, then Q implies P, and then so P implies Q, and Q implies P. This is what gives us the implication of P and Q. So true, true, false, and then false. So this is true, false, true, and then false. Remember, in our earlier discussion on P implies Q, we say that everything is true apart from the first statement, what we call the premise is true, and then the conclusion is false. So true, false is what gives us a false value, but other things are always true. And then now when we reverse the order, Q implies P. So then the premise is Q column, and then P is the conclusion. So you check in this column where we are starting with true value and ending with false. That is what will be false. And if this is true, then false. So this is false, but the rest will be true. Now, so we are joining this column and this column with this connective and. So remember, and from our earlier discussion is only true when both the premise and the conclusion have true, true. So true, true will give us true. False, true will give us false. True, false will give us false. And then true, true will give us true. So therefore, we conclude that hence the biconditional of P and Q is true only when both P and Q have the same or identical truth values. Otherwise, we'll get false. So that's how we interpret the biconditional connective. Thank you.